And here we go. We're back again with some geometry on the Mastermind channel. Chapter 4, Lessons 1 and 2, Classifying and Angles of Triangles. So, you already are familiar with the acute, the obtuse, and the right triangle. Acute means all the angles are acute. Obtuse means there's one obtuse angle, and a right means there's one right angle. Now we're also looking at, there's one to learn, that is the equiangular. Okay, you're familiar with equilateral. Now we have equiangular triangle. That means all the angles are the same measure. There are three congruent acute angles. So, we classify this as acute, equiangular, obtuse, or right. It has three acute angles, and they are not all equal, so it is acute. What about this one? There is one right angle, so this is a right triangle. Now, if I want to look at PQR and classify this one, we know angle P is 45, that's acute, angle R is acute. But what about angle Q? Well, I can use the angle addition postulate, saying 45 plus 59 gives us 104. That is obtuse. So it is an obtuse triangle. Classifying them by their sides, you know the equilateral triangle that has three congruent sides. Every side is the same measure. Isosceles, iso comes from the same, and sceles is from legs, so two legs that are the same, has at least two congruent sides. And scalene means none of the sides are the same length. So let's look at this. Classify this as equilateral, isosceles, or scalene. Since two sides have the same measure, this is isosceles. Now here, if point M is the midpoint of JL, classify JKM, so this small triangle down here, as equilateral, isosceles, or scalene. So first we'll have to try to figure out the measures. Now we know that M is the midpoint, which means JM and ML are the same length, same measure, definition of midpoint. So add those together, you get JL, that's the segment addition postulate. So we could replace JM with ML since they are equal, substitution. So 2ML is 1.5, and then divide each side by 2. We get this is 0.75. JM and ML are both 0.75. Since these are congruent, this is also 0.75. Then if every side is 0.75, that is an equilateral triangle. Finding the measures. We know that these two sides are equilateral, so we can set them equal. Solve each side. We get x is equal to 1.5. Now, that's not enough. That doesn't mean the side is 1.5. It means we can insert 1.5 here. So then we get this side is 7, and since AC is congruent to CB, that side is also 7. Now we can plug in 1.5 for x in the side AB, and we get that side is 12.5. 4.1, the triangle sum theorem, says the measures of all the angles add up to 180. Now, if I want to find missing measures in a triangle, I know they all add up to 180. Let's make this a little more clear. This is what those triangles look like. Find the measure of each numbered angle. So we want to find 1, 2, and 3. Well, the easiest to find will be angle 3, because we know these three add up to 180. So combine these two and subtract them from 180. That leaves us with a measure of 82. Now 78 and 2, those are vertical angles, which means they have the same measure. And then finally, since we know this one, now we can find angle 1. Adding these together, subtracting them from 180, and we get the measure of angle 1 is 41. Exterior angles and remote interior angles. Exterior would be on the outside of the triangle. Interior are on the inside. So the exterior angle here would be 4. Remote, that means far away. So 2 is not far away from 4. Remote interior angles would be 1 and 3 to angle 4. The exterior angle theorem tells us that the two measures of angle A and B, the remote measures, are equal to the exterior angle. So if I want to find this exterior angle, I know that these two remote interior angles add up to the same measure. So x plus 50 is equal to 2x minus 15. Solve this, bring x to one side, add 15 to each side, and you get x is 65. We want to find the measure of JKL. JKL is this angle, so now we found x. Now we've got to substitute that in for x. And that gives us a measure of 115. Corollary is a theorem with a proof that follows as a direct result of another theorem. Corollaries can be used as a reason in a proof. That means if something has been proved and it automatically proves something else, that's a corollary. So, for example, a corollary of the triangle sum theorem. If all the angles add up to 180, if one of them is 90, since they all add up to 180, the other two have to add up to 90. That's 4.1. The acute angles of the right triangle are complementary. It's a corollary to the angle sum theorem. And there can be at most one right or obtuse angle in a triangle, since they add up to 180. Find the measures of each numbered angle. We want to start with 1. We know this is 52, this is 90, so together they add up to 180. Combine them and subtract from 180, you get 38 here. Find measure 2. Go ahead and pause it, find 2, 3, and 4 for yourself, and then I will reveal. Alright, hopefully you paused it and you're back now. We have measure 2. We know these two, and that gives us 52. Once we've combined, now we know that these add up to 90 degrees, 2 and 3. So 52 subtracted from 90 gives us 38 for this measure. We know that this measure down here is 90, 38, and so for 4 we subtract those from 180 and we get 52. And that's all for today, folks. See you tomorrow.